This is a two-part experiment on the magnetic field of a plain coil. In the first part of the experiment, we're going to be measuring the strength of the magnetic field at the center of a plain coil of N turns as a function of the amount of current passing through the coil, and make a graph and analyze that based upon the formula for the magnetic field at the center of a plain coil of N turns. Then in part two of the experiment, we're going to fix the current and then measure the magnetic field along the axis of symmetry of the coil at various positions measured from the center of the coil. Find the magnetic field as a function of x along the axis of symmetry. So the equipment we'll be using is the plain coil of N turns. The radius of that coil we will display in the data at the end of the experiment, but the radius is 10.5 centimeters. The number of coils is 200. And we will increase the current in 50 milliamp increments from 0 up to 250 milliamps. We do have a magnetic field sensor that is going to be placed at the location to measure the field, and we'll be measuring the current with the ammeter connected to the power supply. Data will be taken on the computer displayed over on the left. So the first thing we'll need to do is to zero out the current. We can do that by disconnecting the power supply from the coil, and then zero out the magnetic field meter so that the ambient magnetic field of the Earth will not contaminate our values. So I'm going to go ahead and click the zeroing button, which will zero out the ambient magnetic field. At this point, we will reconnect the supply. Make sure the ammeter is ready to register. Make sure that the sensor is positioned at the very center of the coil, pointing along the axis, and then begin the data taking. So the first thing we'll do is to have zero current to 1 milliamp accuracy. This is zero current, and we'll tell this that this is at the value 0, and keep that data point, and then current is equal to 0. Then what we'll do is to increase the current to 50 milliamps. And then we'll keep that data point, and then this would be 0.05 amperes, 0.050 amperes, and then keep that one. And then as we continue in that fashion up to 250 milliamps, we will generate a data set that I will make available at the conclusion of the experiment. So that is the process that will take the first part of the experiment. The remainder of the experiment will have to start a new application. So I will shut this down for a few minutes, and then we'll start up again when that second application is prepared. So for part two of the experiment, we're going to be measuring the magnetic field along the axis of the same coil, 200 turn coil, radius 10.5 centimeters, as a function of position along the axis, all the way from the 14 centimeter point, which is on one side of the coil being centered at approximately 30 centimeter point, to an equal distance on the other side of the coil at 2 centimeter increments. So I've adjusted the current now to 250 milliamps, and what we'll do is to begin taking data. And at this point, I'm going to keep my first data point, keep. The position is at 0.14 meter. And we'll keep that data point. Then we'll move the magnetic field sensor to the 16 centimeter point along the axis. Get the reading stabilized and keep that data point and enter the position as 0.16 meter. I'll just take one more data point to give the idea. We'll continue taking the magnetic field sensor to the 18 centimeter point, again making sure it's pointing along the axis. Enter the data point, keep, entry is 0.18 centimeter, rather 0.18 meter, okay. In this way we're going to be generating the full set of data which we will present to you at the conclusion of the experiment.